All right, welcome back to day 2 of multiplication properties of exponents. So today we're going to talk about, well, what if I'm taking a power to a power? So notice the first one, I have these little exponents outside of parentheses, right? So that would be a power taken to another power. Well, if I take a look at this in expanded form, let's look at the outside exponent first. That means everything in the parentheses is going to the third power. So that would mean I'm doing 5 squared times 5 squared times 5 squared. But then each of these 5s is going 2 times, so I would expand it even further. So then if you look, that gives me a total of 6 5s, which then I would rewrite as 5 to the 6th power. So look at the next one. The next one, I look at the outside exponent, I'm taking everything in these brackets to the second power. So I just write this twice. So that would look like -3 in parentheses squared times -3 in parentheses squared. So now expand those -3 squareds. The negative is being multiplied here because it's inside parentheses. So I'm doing -3 times -3 times -3 times -3, it should be 4 times. So it's a total of 4 times. And then I would rewrite this as -3 to the 4th power. It is very important the -3 goes in parentheses because the negative is being taken to the 4th power. So let's take a look at the next one. I've got to the 4th power on the outside here. That means I'm taking b squared to the 4th power. So I'm doing b squared times b squared times b squared times b squared. Well, now I need to expand all my b squareds. So that would be b times b times another b times b times another b times b times one more b times b. If I count those up, that's a total of 8 b's. So that would be rewritten as b to the 8th. Let's take a look at the next one. The next one, I'm taking everything in parentheses to the 2nd power. So that would be x to the 5th to the 2nd power. So that would be rewritten as x to the 5th times x to the 5th, right? Well, now I have to take out the x to the 5ths. So I'm going to have x times x times x times x times x times 5 more x's. So 1, 2, 3, 4, 5 x's. Count those up, that's a total of 10 x's, which I would say is x to the 10th power. So now let's go ahead and take a look here. We want to skip this part here, right? How am I getting from here to here? Well, if you take a look at your exponents. I'm multiplying the exponents. 2 times 3. 2 times 3 is 6. Here, my exponents are 2 and 2. Isn't 2 times 2 4? And that's the exponent that I ended up getting on my answer. 2 times 4 is 8. So my exponents were 2 and 4. That gives me 8. And now the next one, I have 5 and 2. And 5 times 2 does give me 10. So it does actually work on all of them. So I think it's safe to say that when raising a power to a power, what are we doing to those exponents? Well, we're just multiplying them. So we multiply the exponents. Now let's do some examples. So the whole idea with having a rule now is that we don't actually need to expand this 3 times and then expand it 4 times because we now know I could just multiply the exponents. 4 times 3 is 12. So this could be rewritten as y to the 12th power. Now I want you to stop the video and try the next 5 on your own and then tune back in and see if you've gotten it. So then if you take a look at each one, all I did is I multiplied the exponents. Think about if we had done this one in an expanded form. We would have had 140 y's. So it's a lot easier to just have a rule. And here we would have had 50 g's and 24 c's and 10 g's. And then this one again is me just trying to get you to really think through the rule. If you're taking a power to a power, meaning you have a little exponent on the outside of parentheses, you just multiply your exponents. So this just gives you 5 to the c times d. Let's look at the next section. All right, now this next section is talking about taking a product to a power. So what that means, or a power of a product, what that means is that you've got a multiplication problem inside the parentheses, and that's going to a power. So for example, if I have 3 times 4 to the second power, well, what that means is I'm doing everything inside the parentheses twice. So I'm doing 3 times 4 times another 3 times 4. Now, since this is all multiplication, it's okay to just remove the parentheses, and then I could rearrange the factors. What property says that I can rearrange factors when I'm multiplying? The commutative property. So I'm just going to abbreviate commutative property in here. If you're spelling it all the way out, don't forget it has a T in it, not an N. Now the next thing I do is I can now look, I've got 2 3s, so I could rewrite that as 3 squared, and I've got 2 4s, so I could rewrite that as 4 squared. So now let's take a look at this. Here I have 4xy, and I'm taking that to the third power. So what that would mean is I'm doing 4xy times 4xy times 4xy. So now if I remove the parentheses, it's all multiplication, and I separate it all. What this just means is I'm doing 4 times x times y times 4 times x times y times another 4 times x times y. So if I rearrange everything, well, we know what 4 times 4 times 4 is, right? So we could put all the 4's together, and then we could put all the x's together. So x times x times x, and then we could put all the y's together. So y times y times y. So then I can rewrite this with exponents, and I would make it 4 to the third power, x to the third power, and y to the third power. Let's go ahead and take a look at the next one. So the next one is saying I'm doing negative 2y to the fourth power. So go ahead and expand that. You've got negative 2y 4 times. Do it with me. Negative 2y times negative 2y times negative 2y times another negative 2y. If you remove your parentheses, it's just all multiplication. So that just means I'm doing negative 2 times y times negative 2 times y times negative 2 times y times negative 2 times y. So I have a total of 4 negative 2's. So that would mean, if I rearrange it, it's negative 2 times negative 2 times negative 2 times negative 2. My little negatives are getting caught. And then I've got 4 y's. Y times y times y times y. So I could rewrite this as negative 2 to the fourth power y to the fourth power. Now let's take a look at the next one. This one is saying negative w to the fifth power. So that means I'm doing negative w 5 times. So we're going to rewrite this as negative w times negative w times negative w times negative w times another negative w. Now, I want to remind you that that negative sign, remember the other day I talked about it's really safe for us to make the negative signs negative ones. The negative signs get really tricky with exponents, so we're going to go ahead and just type in a negative 1, a negative 1, a negative 1, a negative 1, and a negative 1. So what we're doing is we're ending up doing negative 1 5 times. So really, if I rewrite it, this is really like saying negative 1 times w times 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 1 more negative 1 times w. So if we rearrange it, it's like I have 5 negative 1's being multiplied together. 1, 2, 3, 4, 5, and then 5 w's being multiplied together. So if I rewrite this, this would be like negative 1 to the 5th power w to the 5th power. Okay? So the negatives, we're going to treat them like negative 1s. So let's take a look at another one. So this next one is saying I'm taking negative wy to the 2nd power. So I'm going to do this 2 times. So it's going to be negative wy times another negative wy. So then when I rewrite it, let's treat this like it's a negative 1 wy and a negative 1 wy. So when I remove the parentheses, it's going to be like negative 1 times w times y times negative 1 times w times y. When I rearrange it, it's like I'm doing negative 1 times negative 1 times w times y times y. So then if I rewrite it with exponents, that just means I'm doing negative 1 squared w squared y squared. All right? Now, these right here, I want you to take a look at. These are not my final answer because we're actually going to do these exponents, but in order to get the rule, when a product is raised to a power, what are we doing? So go ahead and take a look at what's happening here, and then what's my answer here. Well, if you take a look, what I'm doing is I'm just taking my little exponent and I'm just putting it on every factor, right? So this one gave me 4 to the 3rd, x to the 3rd, y to the 3rd, negative 2 to the 4th, y to the 4th, negative 1 to the 5th, w to the 5th, negative 1 to the 2nd, w to the 2nd, y to the 2nd. So it's kind of like you're distributing. It's not called distributing though, but you're taking the exponent and you're bringing it in to all the factors inside the parentheses. So when a product is raised to a power, my rule is that we're going to say that you apply the exponent to all the factors. Okay? But the other piece that we haven't done yet is that we would then have to simplify it completely. So if you go back and take a look at this, we would not leave this problem as 3 squared times 4 squared. That would be 9 times 16, which would end up being 144. Okay? This next one, we wouldn't leave that as 4 cubed. We would actually do 4 cubed. So this is actually 64 x cubed y cubed. This we would actually do negative 2 to the 4th. Now remember, a negative to an even power will always result in a positive. Reminder, up here at the top, take a look. If I'm doing negative 2 times negative 2 times negative 2, when it's an even power, my negatives always pair up to give me positives. So this would end up giving me 4 times 4, which is 16. So this answer would end up, its final answer would be 16 y to the 4th. This one, negative 1 to the 5th. Remember, if you have an odd power, you have all your next negatives get paired up, but you're going to have 1 left over. So this is going to be negative 1 w to the 5th. But in my final answer, I can just write it as negative w to the 5th, right? The negatives start to get a little bit crazy. And the next one, negative 1 squared, ends up giving me positive 1, which is just going to end up with 1 y squared, or w squared y squared, and you don't need the 1 there, so this would just be w squared y squared. Okay, so now, let's go ahead and try some of these, and we're going to end up getting the final answer. All right, so basically I'm taking this 3 and I'm just applying it to all the factors when I bring it in. So this final answer, without having to expand it, is just going to end up giving me a to the 3rd, b to the 3rd, c to the 3rd, d to the 3rd. And that's my final answer. For this next one, you take the outside 2, you bring it in, and you end up getting 4 squared m squared p squared, but we have to finish it by doing 4 squared. 4 squared is 16. So the final answer would be 16 m squared p squared. Stop the video and try C and D on your own. All right, so when you bring this 4 in, you're doing negative 2 to the 4th power. This negative 2 is in parentheses, so when you rewrite it, it's negative 2 in parentheses to the 4th power, r to the 4th power, s to the 4th power. Then you have to finish the negative 2 to the 4th power. Negative 2 to the 4th power gives you positive 16. So your final answer is 16r to the 4th, s to the 4th. Okay? In letter D, a reminder that negative sign, we have to treat it like there's a negative 1 there. So when I rewrote the problem, I did negative 1 to the 13th, e to the 13th, f to the 13th. Now, when you take negative 1 to the 13th power, just think about it. When you have 13 negative 1s, they're all going to pair up except for the last one. So this is going to end up with a negative 1. So now in my final answer, we could write negative 1 e to the 13th, f to the 13th, or we could just leave it as a negative. And that's the most simplified version, is to just say my final answer is negative e to the 13th, f to the 13th. All right? Now let's take a look at the next ones. The next ones now, if you look, I have a bunch of exponents in here. So now we have to take the first rule that we learned, right? When I take an outside exponent in, what's the rule? This is a power to a power. So what operation do I do here? I multiply. So this would end up giving me a to the 6th, because 3 times 2 is 6. So a to the 6th, b to the 9th, because you would do 3 times 3, c to the 12th, because you would multiply 4 times 3 is 12, and then the last one would be d to the 3rd. And technically, if you think about it, the little exponent there on the d would be 1, so you are multiplying 3 times 1. Now, try f on your own. So stop the video, try f on your own, and then tune back in. We'll do g and h together. So again, if you take a look, I'm doing negative 5 to the 2nd, m to the 6th, p to the 10th. This counts as a factor, so you have to take that to the 2nd power as well. So if you think about it, you might want to just put a little 1 on everything that doesn't have an exponent on it, because now when you bring it in, you're multiplying the exponents. Then you have to finish this problem, and negative 5 squared is 25. So the final answer would be 25 m to the 6th, p to the 10th. All right, now let's look at G and H, because they're kind of tricky. All right, so this one, I want you to remember that that negative sign is actually a negative 1. So I'm going to just go ahead and put a negative 1 in there. So I'm going to put negative 1 right there. So now if you think about it, I'm going to put a little 1 here. Then you bring the 3 in, and so you're taking 2 things to the 3rd power. You're taking negative 1 to the 3rd power, and then you multiply the exponents of 2 and 3, and it becomes a to the 6th. But then you have to simplify negative 1 to the 3rd power. So remember, a negative number taken to the 3rd power will always result in a negative. So this final answer, this part is a negative. So that would be negative a to the 6th. Now the next one's a little bit different, because this one is saying you've got parentheses and you've got brackets. So what you have to do first is go ahead and do these exponents, but you have to keep this negative a in parentheses because it's currently in parentheses. So when I rewrite this, I'm going to write this as negative a in parentheses to the 6th power, because what I did just now is I multiplied my exponents. But now I still have to get rid of these parentheses. So now when I bring this to the whole things to the 6th power, it's like you're doing negative 1 to the 6th power, a to the 6th power. So if you really look at it, negative 1 is being taken to the 6th power, which is actually positive. And so you would have positive 1 times a to the 6th, which would just result in positive a to the 6th. So it gets kind of tricky. Now you also don't have to start by multiplying the exponents. If you wanted to, you could simplify this inside of your brackets first and do negative a to the second power. And so that would be like negative 1 squared, which is positive 1, a squared. So really the negative sign is going to the second power. But because it was in brackets, you also could start the problem by multiplying. Either way, you end up with a positive a to the 6 because the negative is going to an even power whether you're going to that one or you multiply and you're going to the 6th power. Either one is fine. Okay? Now, I want you to stop the video and try the next set of problems 100% on your own and then come back in and see if you have the answers correct. All right, so here are the final answers to those 8 problems. So the final answers are in boxes. It's fine with me if you went straight from the problem to the final answer. I put in this step here so you could see what I was actually doing, and it's totally fine. I actually want you to get to a point where you're going from the problem to the answer. So you're kind of doing negative 2 to the 4th in your head and getting the answer. I want you to get there eventually. It's fine if you're putting these intermittent steps in here, but I'm showing you what I'm doing. The other thing I want to point out is in red, I put all these little ones, right? So like every factor, you've got 1, 2, 3 factors here, they all have exponents on them. So you're bringing the 4 to everybody. So like this negative 2, it's like it has an exponent of 1 on it. So you're multiplying 1 times negative 4 to get, or times positive 4 to get that 4 there. So same thing here. I just put a 1 on all the factors that didn't have exponents. And then also when I have negative signs, I'm going ahead and just putting a negative 1 in there so I don't forget that I'm taking that negative to its separate exponent, separate from the variable, okay? If you're struggling with this, make sure you ask someone in your group or you come talk to me. All right, good luck.